Hi everyone. In this video we will go through few 2-marker problems related to multiple and submultiple angles. Now we'll take this problem. If sine A is 3 by 5, find sine 3A, right? Now we don't know what sine 3A is, right? So I will use the method of derivation. So you can always memorize these formulas, sine 3A, cos 3A, tan 3A, right? These are the formulas. You can directly use this formula, right, and get the answer. But I will go through method of derivation because in case you don't remember the formula, you can use the derivation, right? But if you remember the formula, use this formula directly, right? I'll teach both the methods. If you can remember the formula, directly substitute. What is sine 3A? Sine 3A is 3 sine A minus 4 sine cube A. Sine A is 3 by 5. Now we'll substitute. 3 into sine A is 3 by 5 minus 4 3 by 5 into 3 by 5 the whole cube, because this is nothing but sine A into sine A into sine A 3 times. So 3 by 5 3 times, that is 3 by 5 the whole cube. So I'll get 9 by 5 minus 108 by 125. 108 by 125. Now we'll take the LCM. LCM would be 125. This will go 25 times. 5 into 25 is 125 and 125 once. So it's going to be 225 minus 108, which is 117 by 125. This is the answer for sine 3A. Now this is using the formula, right? What if we had to use the derivation, right? Let's go through that. It will be slightly lengthy, so we'll use derivation and solve the sum, right? If you're comfortable by hearting the formula, skip this particular part, right? You don't have to derive, but I'll go through this method, right, in case it is useful for you. Sine 3A can be written as sine 2A plus A, because we need to find sine 3A. Sine 2A is, you can use sine A plus B formula. Use sine A plus B formula. What is sine A plus B? It is sine A cos B plus cos A sine B. This anyway you'll have to remember, right? So it will be sine 2A cos A plus cos 2A into sine A. Now what is sine 2A? Again, what is sine 2A? Sine 2A is actually 2 sine A cos A. That is sine A plus A, which is sine A cos A plus sine A cos A. I'm using this same formula. So this is nothing but 2 sine A cos A, right? Sine 2A is 2 sine A cos A. I'll write this. 2 sine A cos A, and then I already have a cos A here. Plus cos 2A is, now what is cos 2A, right? Cos 2A is cos A plus A. That is cos A into cos A plus sine A into sine A. This is using cos A plus B formula. It should be minus, not plus, right? Because we have plus here. So this is nothing but cos square A minus sine square A, right? We'll substitute this here. Instead of cos 2A, I'll put cos square A minus sine square A. And then I already have a sine A here, right? This one. Now let's simplify this. So I'll get 2 sine A into cos square A plus cos square A into sine A minus sine square A into sine A sine cube A. Now if you notice this, you have 2 sine A cos square A and cos square A sine A, which is nothing but 3 sine A into cos square A. 3 sine A into cos square A minus sine cube A. This is sine 3A, right? This is sine 3A. Now we'll substitute. Sine A is 3 by 5, right? Sine A is 3 by 5. So it is 3 into 3 by 5 into cos square A minus sine A is 3 by 5, the whole cube, right? Now we don't know what is cos square A, right? We have been only given sine A value. Sine A is 3 by 5. What we can do is, this is 9 by 5. I can write cos square A as 1 minus sine square A. Why? Because cos square A plus sine square A is equal to 1. Using this, we can say cos square A is 1 minus sine square A. So instead of cos square A, I'm putting 1 minus sine square A, and sine A is 3 by 5. So I'll put 3 by 5 here, and then minus 27 by 125. On simplifying, we get 117 by 125. So earlier also we got the same answer using direct formula. Here we have used derivation. Only thing, the derivation will be little lengthy, but it is useful to know the method in case you get stuck or you forget the formula. Now let's solve another problem where we have to find the value of 3 sine 10 minus 4 sine cube 10 degrees. Now, in this case, if you can look at this, right, this is nothing but sine 3a formula. Sine 3a is 3 sine a minus 4 sine cube a, right? This is sine 3a formula. And a is nothing but 10 degrees here. This is a here. So this entire thing is sine 3a, right? Sine 3 into a, it is 10 degrees, right? Sine 3 into a. Instead of a, it is 10 degrees. So sine 3 into 10 is nothing but sine 30. What is sine 30 degrees? Sine 30 degrees half. So this is the value of this particular expression, half. Let's go through another problem where we have to prove that cos 2a by 1 plus sine 2a is equal to cos a minus sine a by cos a plus sine a. Now, we will have to substitute formulas for cos 2a and sine 2a. Cos 2a is cos square a minus sine square a. And sine 2a is 2 sine a cos a. Right? I put the derivation also here just for reference. So, these are the formulas. Right? Now, we'll substitute both of these formulas here. Right? First, we'll take the LHS. Right? This is the LHS. And this is the RHS. Right? We'll first take the LHS term and whatever value we get out of this evaluation should be equal to RHS. So, instead of cos 2a, we'll write cos square a minus sine square a. And instead of sine 2a, we'll put 2 sine a cos a. Now, you can write cos square a minus sine square a as cos a plus sine a into cos a minus sine a. There's an important algebraic formula, right? A square minus b square is equal to a plus b into a minus b. Now, if you look at this, this is of that form. This is a square and this is b square. So, if you have a square minus b square form, you can write it as a plus b and a minus b, right? Now, that is how we have done here. Cos a plus sine a, cos a minus sine a. And then we have 1 plus 2 sine a cos a. Now, instead of 1, we can write as sine square a plus cos square a. Because sine square a plus cos square a is 1, right? We'll do that. The reason we are doing this is so that you can get everything in terms of sine a cos a. If you get everything in terms of sine a, then the final answer also will be in terms of sine a and cos a. Now, if you notice this entire denominator, you notice, right? This is of the form a plus b the whole square. What is a plus b the whole square? A square plus b square plus 2ab. This is the formula, algebraic formula, right? Basically, if you multiply a plus b into a plus b 2 times, you will get this expression. When you multiply this with this, this with this, this with this, and this with this, you will get a square plus b square plus 2ab, right? Now, if you notice, it is of the same form. You can write this as a sine, this is of the form sine square a plus cos square a plus 2 sine a cos a. This is of the form a square b square plus 2ab. A is sine a, b is cos a, right? So, now we can write this denominator as sine a plus cos a the whole square, right? We can write it as sine a plus cos a the whole square. Because sine a plus cos a the whole square, if you multiply, right, you will get sine square a plus cos square a plus 2 sine a cos a using this formula, right? So, now we have written it as sine a plus cos a the whole square. Now, let's copy the numerator. What is the numerator? We have cos a plus sine a into cos a minus sine a. Now, we can cancel one of this. Cos a plus sine a plus cos a. One of this will get cancelled. So, you will be left with cos a minus sine a, this one, and one of this. That is sine a plus cos a. So, we have proven this. This is equal to RHS, right? This is nothing but cos a minus sine a. You can write this as cos a plus sine a. I have just interchanged this, right? So, now this is equal to RHS and this is LHS. So, hence we have proven this particular expression. Let's take another problem where we have to prove that 1 plus sin 2 theta by cos 2 theta is 1 plus tan theta by 1 minus tan theta, right? Now, let's first take this as LHS, right? This entire portion as LHS and this entire portion as RHS, right? Now, we'll start with LHS. Now, what we'll do, we'll substitute sin 2 theta. Sin 2 theta is, that is 2 sin theta cos theta. Cos 2 theta is cos square theta minus sin square theta. We'll substitute both of these, right? Then we'll get this one. So, now instead of 1, we can write sin square theta plus cos square theta is equal to 1, right? So, instead of 1, we'll put this. We'll put sine square theta plus cos square theta plus 2 sin theta cos theta. I am copying this. Divided by, now instead of writing cos square theta minus sin square theta, there is an algebraic formula, right? That is a square minus b square is equal to a plus b into a minus b. Now if you notice, this is of the form a square minus b square, right? So you can expand it as a plus b into a minus b. So I can write it as cos theta plus sin theta into cos theta minus sin theta. Now again, you notice this particular expression, right? There is another algebraic formula. What is algebraic formula? It's nothing but a plus b the whole square is a square plus b square plus 2ab. This is the algebraic formula. Now you notice this expression. This is of the form a square plus b square plus 2 into a into b, right? This is of this form, where a is sin theta, b is cos theta, right? This entire expression can be written as a plus b the whole square. That is sin theta plus cos theta the whole square, right? You can write it as sin theta plus cos theta the whole square, because sin theta is like a, cos theta is like b, right? And then we have this denominator. Now if you notice, you can cancel one of the terms, right? You can cancel this one and this one, and then you'll be left with 1 sin theta plus cos theta. I'll be left with sin theta plus cos theta by cos theta minus sin theta. Now what do we do next? We need to get RHS in terms of tan, right? This is the RHS. We need to get this expression. How do we get? What we've got is in terms of sin, but we want in terms of tan. What we can do is, we know that sin by cos is tan, right? Sin by cos theta is tan theta. So we have sin theta. If you divide by cos theta, you will get tan theta, right? If you divide sin theta by cos theta, you will get tan theta. So what I'll do is, I will divide numerator and denominator by cos theta. Both numerator and denominator by cos theta. Let's divide numerator and denominator by cos theta to get tan theta. So this is nothing but sin theta plus cos theta by cos theta by cos theta minus sin theta. Again you divide this also by cos theta. So you have divided both numerator and denominator by cos theta. So now we will split. We'll split this. We'll split this. Why will split? So that we can get tan theta out. So I'll make this as sin theta by cos theta plus cos theta by cos theta. Similarly in the denominator I'll split. So I'll get cos theta by cos theta minus sin theta by cos theta. I've split this separately. So now cos theta and cos theta will get cancelled. Here also it will get cancelled. You'll be left with sin theta by cos theta is tan theta plus 1 by, this will be 1 minus sin theta by cos theta is tan theta. So we have got the RHS. So we have proven this particular expression. LHS is equal to RHS, which is equal to 1 plus tan theta by 1 minus tan theta. Now let's take this problem. Prove that sin A plus sin 2A by 1 plus cos A plus cos 2A is tan A. Right? So using multiple angles and compound angle formula, we'll try to prove this. So two formulas majorly for sin 2A and cos 2A. Sin 2A is 2 sin A cos A. Cos 2A is 2 cos square A minus 1. Now again there are three formulas here, right? As you know, you have cos square A minus sin square A. Then you have 2 cos square A minus 1. Then you have 1 minus 2 sin square A. Right? Three formulas are there, and one is based out of tan. Right? So now we'll take this 2 cos square A minus 1 formula. We'll use this. So I'll substitute. Sin 2A is 2 sin A cos A, and cos 2A is 2 cos square A minus 1. Now let's simplify this. So I've taken sin A common between this. If you take sin A common, you'll be left with 1 plus 2 cos A. Right? I've taken sin A as common. So I'll be left with 1 plus cos 2A. Now here again, 1 and 1 will get cancelled. So 1 minus 1 is 0. Right? And then I'll have cos A and 2 cos square A. I'll be left with this. This and this will get cancelled. Now I'll take cos A common between this. So if I take cos A as common, I'll have 1 plus 2 cos A. Correct? Now if you notice, this and this will get cancelled. You are left with sin A by cos A, which is nothing but tan A, and this is nothing but RHS. So we have proven this. We have proven this entire expression. With this, we've come to the end of this particular topic. Thanks for watching. If you have found this video useful, do like it and share it.